Hello viewers, welcome to our online channel. I am Dr. Archana Chaube from the Department of Chemistry, Bhopal School of Social Sciences. In the last lecture, we have done the first law of thermodynamics. Today, we will be dealing with second law of thermodynamics. So let's begin. In today's lecture, we will be covering the following topics. We will be comparing the two laws for thermodynamics. Then we'll understand the meaning of entropy and spontaneity, factors affecting entropy, and the statement for second law of thermodynamics. When we compare the two laws, the first law of thermodynamics, also termed as the law of conservation of energy, it defines internal energy of thermodynamic systems and expresses its changes for the closed system in terms of work and heat. The first law of thermodynamics states that energy of the universe remains constant. It does not change, even though there is exchange between system and surrounding, but the total energy of the system is defined and it is constant. So, it cannot be created nor destroyed. Therefore, we had used the term law of conservation. Like here, we can see the example. If there is a mixture of, there are two gases which are represented by the colors over here, blue and red dots. The two gases are separated to each other. If they are allowed to mix together, the two will mix and the total disorderedness or the entropy of the system will increase. But if this is the forward reaction, that is mixing of the gases is occurring, and if we want to reverse the reaction, that means to get the separated state back, is it possible on its own? No. Similarly, if I see the example that water is filled in a bucket which is kept at higher altitude, and when this water is connected by a passing tube to another bucket kept at lower altitude, the water automatically flows from the higher altitude towards the lower altitude, which is the normal phenomena. But if we expect the reverse to happen, the thing will do not occur automatically or spontaneously. So, in certain cases, the forward reactions are spontaneous, but if we talk about the reverse reaction, they do not occur spontaneously. They can occur, but with the help of some external force. So, therefore, comes the existence of second law of thermodynamics. The second law is concerned with the direction of the natural processes. As we have spoken about the direction of reaction, that a certain mechanism may occur forward, but it do not occurs in the opposite direction on its own. So, this law asserts that a natural process runs only in one direction and it might not be reversible. The second law of thermodynamics, it puts restrictions on the directions of the heat transfer and the achievability of efficiency of heat engine. For example, if we take and look at this figure, if we have a heated object which is connected to another cold object by a conductor connecting the two, so the heat is allowed to pass automatically and spontaneously from the hotter object to the colder object passing through the conductor. So, this forward mechanism will occur until the two has achieved the same temperature and then the process will stop. But if we expect the reverse to happen, that will do not occur. So, such phenomena, these are accounted for the terms of change in entropy, because when the movement is occurring, more is the entropy of the system. So, now what is the need for the law, the second law of thermodynamics? Since the first law of thermodynamics, it is giving us the information about the quantity of energy in terms of heat and work, but it do not gives us the information, or it fails to provide an insight about the direction of the flow of energy in the particular process. So, a process will do not occur successfully if it do not obeys both the laws of thermodynamics. The second law of thermodynamics, it states that any spontaneously occurring process will always lead to increase or escalation of entropy. Entropy is represented by the letter capital S, and the entropy of the universe is continuously increasing, or in simple words, what do we say? The law explains that in an isolated system, entropy will never become zero, it never decreases over time. Like the picture over here clearly explains, when the molecules are at high randomness, they have highest entropy, because entropy actually talks about the disorderedness of the system. The more disordered a system is, the more higher will be the entropy, and as the system gradually becomes ordered, it has lowest level of entropy, but still it will never be zero. So, if we talk about the efficiency of engines, the second law of thermodynamics also states that it is impossible to convert heat energy into mechanical energy with 100% efficiency. This is the concept behind the working of engines. Like if we take the example of a piston in an engine, when the gas which is filled in it is heated, to increase it exerts on heating, the gas will expand and it will exert pressure on the piston, due to which the piston will move upwards. But during this process, what will happen, even when the gas has completely expanded and 100% process has been achieved, some part of the gas will be left which is unused, and this part of the that means certain part of the process has not been utilized into the process of work, that is movement of the piston, and it has been wasted. So, this is the part which is actually termed as the discarded energy. So, heat over here has got wasted in some part and it has been discarded. So, in case if we talk about the case of piston, here the energy or the heat goes into the sink, whereas the car engines also work on the same principle. So, here the energy, the fuel is the source of energy, but 100% fuel does not give us the efficiency to move the car. Some part of the fuel is wasted, and it is wasted in the form of the exhaust which comes out from the vehicles, and it moves into the air and mixes in the atmosphere. Also, when the piston moves, there is an opposing force which do not allows the smooth functioning, which is known as the friction, the opposite of the smooth movement of the piston. So, the frictional force also resists the 100% efficiency of the piston. So, if we talk about the second law, the mathematical statement of second law of thermodynamics represent that change in entropy of the universe is never equal to 0. It will always be more than 0, where delta S represents the change in entropy in the universe. And we have been talking about the term entropy. So, I have already told you what is entropy. Entropy is actually the measure of randomness of the system. We can also say it is the measure of the energy or the chaos, the disturbance which is there. Higher the value of entropy, more spontaneous would be the reactions, because every system in the nature wants to achieve stability. So, it from randomness or disorderedness, they do want to achieve the ordered situation. So, now let us see what are the factors that cause increase in entropy in closed systems. Like in the first lecture, we have discussed about 3 systems: closed systems, open system and isolated system. Here we are talking about entropy in case of closed system. So, in case of closed systems are those in which the system and surrounding are not in contact with each other. So, first, when we are talking about a closed system, while the mass remains constant because there is no exchange of matter, but there is exchange of heat can occur, but exchange of heat is occurring with the surrounding, because we are not talking about the isolated system. It is only the exchange of matter is not possible. Like the example that we had taken was a small cup filled with hot tea or coffee and which is covered with a lid. So, even it does not cool immediately, but after some time it will automatically cool, because the exchange of heat is taking place, but there is no exchange of matter, that is, and the matter is not being allowed to escape into the surrounding. So, such system is an example of closed system. So, in a closed system, when there is no exchange of matter, it remains constant, but heat is still being exchanged with the surrounding, and this change of heat causes disturbance in the system. So, there is exchange of heat from within the system to outside, but as we have seen, the spontaneity of the reverse reaction is not possible. So, this exchange of heat causes disturbance in the system, and therefore it increases the entropy of the system. So, first factor which increases the entropy of the system is the exchange of heat with the surrounding. And what is the second factor? The second factor that causes increase in entropy is the change of the state of the system. Like for example, we can see as the solid, when it melts into liquid and which further changes into gas, the distance between the atoms or the molecules will increase, thus increasing randomness or entropy of the system. So, now coming to the actual statement for the second law, there had been many statements given. So, the one of the most important statement is that given by Clausius. What does it state? It is impossible to construct a device operating in a cycle that can transfer heat from colder body to a warmer body without consuming any work. Also, energy will flow spontaneously from lower temperature objects to higher temperature objects. They are saying that it is actually not possible to construct a device. It is not that the phenomena is not possible, but the process will not occur automatically. So, it is impossible to construct a device which is operating in a cyclic process where transfer of heat has to be done from cold object to warm object, because the normal process is from warm to cold. If we want the opposite to occur, so that will not occur spontaneously. There has to be some external force, some work has to be done. With the help of that, the opposite process is possible. So, like in this aspect only, the modern refrigerators work, that in case of refrigerators, they actually it is the cold reservoir which takes its heat and it passes to the hot reservoir, due to which the freezers they cool. Whereas, but this do not occur on its own. We need a machine, a compressor to do that process, because naturally such a phenomena is not possible. Because if it would have been possible, then the refrigerators would have worked without the help of a compressor. So, the opposite of it will forbidden, or it is opposite to the second law of thermodynamics. So, we must always remember the two important examples in our daily life where we see the obeying of second law. It is in the working of refrigerator and the engines and pistons in our vehicles. One more simple example if we take from our day-to-day life is that, since we have said that second law is saying it is impossible for heat to flow uphill on its own. Uphill means from lower temperature to higher temperature. As water is moving from higher altitudes to lower altitudes, similarly heat flows from higher temperature to lower temperature. So, the opposite phenomena is not possible on its own. Like a simple example we can see in our day-to-day life in the kitchen. If a pan of boiling water is put in contact with a pan containing ice, the water will boil, and as the water will boil, the ice which is kept on it will start melting, and this process will continue, and after some time the water has taken the heat, and that heat transfers to the lid, due to which the ice which is kept on it starts melting. But is it possible that the other way round will occur, that the ice will freeze again and the water does not boil so vigorously? No, this is not possible. The heat flow is always downhill from the object at higher temperature to the one at lower temperature, and the uphill movement is impossible. Therefore, the second law cannot be disobeyed in any of the situations in our day-to-day life. So, that is it for today. In the next class, we will understand some important terms of thermodynamics. Thank you.